What is PLC? Welcome to our journey into the world of programmable logic controllers, or PLCs. Today, we'll explore what PLCs are and trace their fascinating history from inception to modern-day applications. Introduction to PLCs. PLCs are specialized computers used to control machinery and processes in industrial environments. They are designed to handle multiple inputs and outputs, making them ideal for automating complex tasks in manufacturing, energy, and other industries. The birth of PLCs. The story of PLCs begins in the late 1960s. Before PLCs, industrial automation relied heavily on relay-based control systems. These systems were bulky, complex, and difficult to reconfigure. In 1968, a major breakthrough occurred. Richard "Dig" Morley, often referred to as the father of the PLC, developed the first PLC for General Motors. This invention revolutionized industrial automation by replacing the cumbersome relay systems with a more flexible and programmable solution. Evolution of PLCs. The first PLC, known as the Modicon 084, was a game-changer. It allowed for easier programming and reconfiguration, significantly reducing downtime and maintenance costs. Throughout the 1970s and 1980s, PLC technology continued to evolve. Manufacturers like Allen Bradley, Siemens, and Mitsubishi entered the market, each contributing to the advancement of PLC capabilities. Modern PLC. Today, PLCs are more powerful and versatile than ever. They integrate seamlessly with other industrial systems and support advanced features like real-time data processing, remote monitoring, and IoT connectivity. Modern PLCs are used in a wide range of applications, from controlling assembly lines in automotive factories to managing complex processes in chemical plants. Their reliability and flexibility make them indispensable in today's industrial landscape. Key components of a PLC. Let's take a closer look at the key components of a PLC. Central Processing Unit. The CPU is the brain of the PLC. It executes control instructions based on the program stored in its memory. Input, output, modules. I/O modules connect the PLC to sensors and actuators. Inputs can include signals from switches, sensors, and other devices, while outputs control motors, valves, and other actuators. Power supply. The power supply provides the necessary electrical power for the PLC and its components. Programming device. The programming device, often a computer, is used to create and upload the control program to the PLC. Stay tuned. Subscribe and follow for more.